Alright, so for this video we're going to go over momentum. So momentum is the quantity of motion. It is a vector quantity. So it will have a direction just like force or velocity will. It is measured in kilograms times meters per second. And you can get the momentum by taking the mass and multiplying it by the velocity. And when you see it, it's actually going to be little p is equal to m times v. Now, you can also solve for the change in momentum, which will be useful if you have an object that will stop, change directions, or the speed changes. So if any of these events happen, you can solve for the change in momentum, and the only real difference there is that you would take the final velocity minus the initial and multiply that to the mass, and that would give you the change. Okay, so momentum deals with force. So basically, if you have a force can cause a change in the object's momentum. So basically, it can stop the object, change the velocity, or change the speed. So you can use this equation to solve for force or time with the momentum. So your force multiplied by your time is equal to the mass multiplied by the change in velocity. And some good applications of this momentum impulse theory deal with time and the force necessary to change a velocity. So if you stop something, you might want to know the force it takes to do that, like stopping a roller coaster or stopping somebody from falling. Now, when you're looking at this equation, if you have more time, that means that your change in velocity can be greater. So a good example of this would be when a coach tells you to follow through with a bat swing. That means that if you follow through, you're going to spend more time in contact with the baseball, and that's going to cause a greater change in velocity, which is better because then it will make the ball go out at a greater distance. If you also have more time interacting with this object, this means that less force might be needed to change the momentum. So if you have a car and you drive it through a bale of hay, well, the hay will slow down the car, so that way your force necessary to stop it can be less. Okay, so what force is required to stop Splat the cat, which is 1 kilogram, from falling off a building when his velocity is 40 meters per second in 1 second? Okay, so when you do this, pull out your variables like you always do. So your mass is 1 kilogram. His velocity is 40 meters per second. And then you need to decide if it's the initial or the final. So if we're trying to stop him, he's initially going 40 meters per second, and then his final velocity should just be 0. The time we're given to do this is 1 second, and we are looking for the force. So we have our equation right here. We can just simply plug it in. Our time is 1 second. Our mass is 1 kilogram, and our final velocity is 0, and our initial velocity is 40. So negative 40 times 1 is negative 40. F times 1, well, you just divide both sides by 1, and your force will be negative 40 newtons. So that negative sign just indicates a direction. All right, so momentum is one of those items that happens to be conserved. So when there are no external forces, then momentum is conserved. So no friction, nothing else acting on the act. So a lot of times when we have a momentum problem, it deals with collisions. So if you're reading a question and it's talking about a collision, then that's probably your big clue that it's a momentum problem. All right, so the initial momentum will equal the final momentum as long as there's no external force. So you have this equation. The mass of the first object multiplied by the velocity of the first object will give you the momentum initially, and then you'll basically get the momentum of each object that happens to be in the collision, get the initial momentum, the total initial momentum, and you're comparing that to the final total momentum. So your collisions can either be elastic or inelastic. Elastic collisions, the objects are going to break apart and go off in different directions. The kinetic energy will be conserved in a perfectly elastic collision. So if there's no outside force, then you will have a total conservation of kinetic energy. Now, in an inelastic collision, the objects will stick together. So in the end, there's one mass and one final velocity. And this is the equation you will use if it happens to be an inelastic collision. Basically, you'll take the mass of the first object, the mass of the second object, because they're going to be moving together, and then multiply that to the final velocity, because again, they're going to be moving together. All right, so let's just do a problem. I'm only going to do one type of problem. So if you can do this type of problem, you should be able to do the other type. So what you'll do is you'll do a before and after table. Okay, so you have two different objects here. In this case, you have a hockey puck and then a hockey player, a goalie. So before the collision, you have a puck. The mass of the puck is 0.105 kilograms. Your velocity of the puck is 48 meters per second. And then you have another object, which is the goalie. Okay, the goalie has a mass of 75 kilograms. Velocity of the goalie, well, he's at rest, so 0. And then afterwards, mass will still be the same for both objects. Okay, and your velocity is unknown. And since these two things are going to be moving together, you only have one final velocity. So if you have a hockey puck that's moving towards a goalie, ideally the goalie will have caught the hockey puck, so they will be moving together. All right, so basically what we'll do, let's find the initial momentum before. So the initial momentum, well, of this first object will be m times v, so 0.105 multiplied by 48. Okay, so your initial momentum here is 5.04. So right here of the other object, 0 times 75 is just 0. So you will have to add these two together to get your initial momentum. So your initial momentum of the puck is 5.04. The initial momentum of the hockey player is 0. So that's really just 5.04. That will be equal to the momentum afterwards. Well, since there's only one mass that we're concerned with, and there's only one mass that we're concerned with and one velocity, we need to add the masses together. So 0.105 plus 75 will give me 75.105 multiplied by my unknown velocity. So at this point, I can just solve by dividing both sides by 75. So your final velocity here is 0.067 meters per second. Okay, so right here we have a very slow velocity, and really that makes sense because the goalie is much more massive compared to the hockey puck. So the hockey puck's not going to be able to move this person very much. Okay, so whenever you have a collision problem, set up a before and after table, and if anything equals 0, you can cancel it out. But basically, you're just trying to find the momentum before the collision, the total momentum, and then that's equal to the total momentum after the equation, or after the collision.